All right. This explosion problem is a little more involved than it might first look. You've got this toy cannon with a mass of 1 kilogram, initially at rest on a horizontal surface. When it launches a 500th kilogram projectile with a velocity of 10 meters per second at an angle 60 degrees above the horizontal. What is the speed of the cannon immediately after the projectile is released? All right, this is an explosion. Again, collisions, explosions, you're thinking momentum. Momentum is conserved. Momentum initial equals momentum final. The momentum initial here is very simple. You've got a toy cannon, M1, V1. You've got the cannonball, M2, V2. They are both at rest. So the initial momentum is 0. It's not moving, which means after the explosion, the final momentum has got to equal 0. So after the explosion, the momentum of the cannon plus the momentum of the cannon, the mass of the cannon times the mass of the cannonball plus the mass of the cannonball times the speed of the cannonball, mass of the cannon, velocity of the cannon, mass of the cannonball, velocity of the cannonball. All that has got to equal 0 after the collision. So you're going to get the mass of the cannon multiplied by the speed of the cannon, we call that recoil, is going to be equal to the mass of the cannonball times the velocity of the cannonball. One of these things is going to be going in opposite directions, so really the speed would be negative. So we'd say this minus that, because one is positive, one is negative, right? If you think of it like a typical cannon scenario. Here's the cannon, or the cannon looks like that. It's going to shoot the cannonball that way. The cannonball is going to be moving to the right. The cannon is going to recoil to the left. So one of these would be positive, one of these would be negative. So when you bring them there, you get we'd call that recoil. Now the thing of it is, what makes this a little tricky is that this thing is fired at an angle. The cannon is fired at an angle, 60 degrees. So that color's no good. Fired at an angle of 60 degrees. So momentum is a vector. You got to pay attention to here just the x direction. Very confusing. We'll talk about this at the very end. But the momentum in the y direction is not conserved in this case. Right? This thing fires up. I mean, the cannon will have to go down. But that's not happening. If the net forces are not 0, momentum is not conserved. When the cannon fires, if we had a bathroom scale underneath this thing, measuring its weight, when this thing fires, the force down is not equal, it's not balanced. The forces here are not balanced. There's got to be a greater force up to prevent this thing from moving into the earth. The normal force is going to be much greater than the weight down. So the momentum in the y direction is not conserved because F net in the y direction at the moment of explosion is not 0. They're not balanced. The forces are not balanced. The Earth is pushing up more than the cannon is being pulled down at the moment of explosion. Okay? But momentum is conserved in the x direction. Momentum is conserved. Because in that case, F net in the x direction does equal 0. This is our ideas of isolated closed systems and so forth. All right, so back to this. This is just the x direction. So if this thing gets shot from the cannon at 10 meters per second at 60 degrees, the velocity in the x direction is 10 meters per second times the cosine of 60 degrees. The cosine of 60 degrees is a half, so 10 meters per second times 0.5. The velocity in the x direction is 5 meters per second. That's very important. So we talk about the mass of the cannon. 1 kilogram here times the recoil velocity, that's what we're paying attention to, is equal to the mass of the cannonball, 0.05 kilograms, multiplied by its speed after the explosion, which was 10 meters per second at an angle, or in just the horizontal, it's 5 meters per second. So you get 1 kilogram times the recoil velocity, v1 prime, equals 0.25 kilogram meters per second. Well, divide both sides by 1 kilogram, you get v1 prime, the recoil velocity of the cannon is equal to 0.25 meters per second. A lot of students are going to want to use 10 instead of 5, but momentum's a vector, so you have to break it into its vector components. Which way is the cannon going to recoil? The cannon's not going to recoil down in this direction. The cannon's going to recoil this way, so you only use the velocity to the right because the recoil is going to be just to the left. I hope that makes sense.